Hey everyone, and welcome to a brand new explainer. Today, we're cracking open a piece of tech that is literally shaping our modern world, even though the mechanics of it can honestly feel a bit like a black box. We're going to completely demystify deep learning. We'll look at what it is, how it actually works, and why it's pretty much revolutionizing everything from the smartphone in your pocket to modern healthcare. So, let's start by clearing up the biggest source of confusion right off the bat. What exactly is deep learning? If you follow tech trends at all, you're constantly bombarded with terms like AI, machine learning, and deep learning. And yeah, they're often used interchangeably, but they really aren't the same thing. Think of artificial intelligence as the big, broad umbrella. Tucked inside that is machine learning, and then nested even deeper inside that is our focus for today, deep learning. It's essentially the heavy-hitting engine that's driving this entire modern AI revolution. To truly get why deep learning is such a game changer, we kind of have to look at its older sibling first. Traditional machine learning relies heavily on structured data. Think of neat, orderly rows and columns in an Excel spreadsheet. And crucially, a human actually has to manually tell the algorithm what to look for, like explicitly programming a car pricing algorithm to weigh the horsepower and the color. Deep learning, though, completely flips that script. It doesn't need that neat, structured data. You can feed it raw, messy, unstructured information, like, say, a full digital photograph of a car, and it's smart enough to automatically extract the most important features all by itself. Which brings us to a really clear, simple definition. Deep learning is a highly specialized branch of machine learning that uses artificial neural networks with multiple layers to learn from massive amounts of data. And by the way, that word deep isn't meant to be deep or philosophical. It literally just refers to the physical architecture of the system. It means there are many, many layers of processing happening back to back. Now, if you're wondering how those layers actually function, well, we really only need to look at the ultimate inspiration for this technology, the human brain. When you or I learn to recognize an object, our biological brain is passing signals through billions of interconnected neurons. Deep learning is just mimicking that biological mechanism. Information passes through successive series of artificial nodes. Each node takes the data in, processes it just a little bit, and then passes it forward. It allows the computer system to identify patterns in steps, honestly, a lot like human cognition. The architecture of these neural networks can be elegantly broken down into three super simple stages. Step 1 is the input layer. That's simply where the raw data enters the system. Step 2 is the hidden layers. This is the actual deep part of deep learning. There can be hundreds of these layers stacked together, doing the really heavy lifting of pattern recognition. And finally, step 3 is the output layer, which is where the network delivers its final prediction to us. Let's look at how this builds up. When data enters that input layer, let's say it's raw images of faces. The network isn't actually looking at faces yet. At that stage, it's just processing really basic patterns of local contrast, just light and dark pixels. But as that data pushes deeper into those hidden layers, those simple pixel contrasts start to merge. They become specific features, like an eye or a nose, and eventually it pieces together the entire face right before it hits the output layer. Think of these hidden layers like a set of Russian nesting dolls, where each layer contains and builds upon the previous one. The very first layers identify simple things like vertical lines or edges. Then the next layer combines those lines into basic shapes. The layer after that takes those shapes and builds complex features. By superimposing all of these cumulatively learned patterns on top of each other, the network creates a complex matching function that is just remarkably effective. All right, so theory is great, but let's make this real. How does a computer actually look at a screen full of pixels and confidently recognize a cat? Now, historically, this was a notoriously difficult problem. It baffled computer scientists for decades, mainly because you can't just write a neat mathematical formula for catness. Older computers were famously terrible at this. They'd get completely confused by a shadow or a slightly tilted head. So let's walk through exactly how deep learning solves this puzzle, step by step. Okay, here is our input data, a very serious-looking orange and white cat. Now, in a deep learning system, this doesn't enter the computer as an animal. It enters the input layer as a massive grid of raw pixels. Every single pixel's color value is fed into those initial nodes. So the input layer has absolutely no concept of fur or whiskers at all. It just sees millions of data points representing color and light intensity. Then, the magic happens in the hidden layers. As those raw pixels get pushed forward, the first hidden layer acts as a feature detector for simple lines. Maybe it spots the sharp contrast around the edge of an ear. Then the next layer realizes, oh, those edges form a triangle. Going right back to our nesting dolls analogy, the network automatically assembles these tiny visual fragments, the texture, the shape, the depth, into a highly complex representation of our feline friend. Finally, the whole shebang arrives at the output layer. All those superimposed patterns are run through the network's complex mapping function, and it makes a decision, outputting a mathematical probability. In this specific case, it delivers a score of 0.73. That means it has a 73% confidence that this image is indeed a cat. It took unstructured pixels and, entirely on its own, without any human holding its hand, successfully identified the animal. And that right there brilliantly illustrates exactly why deep learning is the absolute dominant force in tech today. First off, it completely unlocks unstructured data, whether we're talking images, audio files, or massive blocks of text. Second, that automatic feature extraction that saves literally thousands of hours of manual programming. Third, it thrives on massive datasets. The more data you feed it, the smarter the network gets. And finally, it frequently achieves superhuman performance on highly complex tasks. Because of these incredible advantages, deep learning is not just an academic exercise, it is actively powering the world around you right now. When your phone flawlessly transcribes a voicemail, that's deep learning. It's the core engine behind natural language processing and all those new chatbots. It's the critical tech allowing autonomous vehicles to instantly recognize a pedestrian versus a stop sign in the middle of a chaotic intersection. It's even revolutionizing medicine by spotting tiny anomalies in MRI scans way faster than human doctors can. Okay, let's do a rapid-fire recap to really lock all of this in. Deep learning is an incredibly powerful branch of machine learning. It relies on artificial neural networks that are structurally inspired by the human brain. It processes huge datasets by passing them sequentially through input, hidden, and output layers. And by doing this, it automatically solves complex matching problems that older, traditional algorithms simply couldn't handle. So, the next time someone brings up deep learning, you're going to know exactly what's going on under the hood. It's a fascinating technology and one that is only going to become more integrated into our daily lives. Now, I want to hear from you. If you could train a deep learning neural network to automatically solve one complex, tedious task in your own life, what would it be? Drop your ideas in the comments down below. Thank you so much for joining me for this explainer. Keep learning, stay curious, and I'll catch you in the next one.